Hi class. So now we have lesson 4 part C for our second part of our unit 4 videos. And we're still on the theme of personal finance, but now we're going to look at some graphs. So it says, with just a quick glance, what does this graph tell you about average household income? So when you're looking at a graph, in order to understand that graph, you want to read, any labels or axes that are labeled and title and such to figure out what this graph is about before you make any decisions. So over here it says that this is average household income. We start at 48,000, 49,000, 50, 51, 52, and 53,000. Down here we have the years, 1999 to 2009, and it looks like it goes by each year. It doesn't go every 5 years or every 10 years, it's just each year. And then up here it says that this is the average household income in 2009 dollars versus the year. Now this is kind of key to this, or important I should say, maybe not key, but it's important to note that this is in 2009 dollars, which means that this has already been adjusted for inflation. So we don't have to say, oh well, it was at this level, but then with inflation this actually wouldn't have been as much value as it was back in 1999. So like for instance, someone now made or let's go back, if somebody in 1950 made $20,000, that would have been considered quite a bit more money than someone making $20,000 now because of inflation. So this has already been adjusted for inflation, and we don't have to worry about that. It's already in 2009 dollars. So what does it tell you about average household income? Well, if we look at this line, some things that you might notice is it did fluctuate. It went down steadily for a period, then it rose up again, and then it dropped in this area, and from beginning to end it's gone downward. So from 1999 to 2009 the income went downward. So those are some things that you might note. And it says a period of growth in income occurred between which 2 years? So the only time that there was growth, and the way this is worded has always bothered me, but between which 2 years, they're not saying it has to be 2 consecutive years, just any period that there was growth. So from 2004 to 2007 was where there was growth, where there was an increase in the average household income. So those are the 2 years they're talking about, 2004 and 2007. It says, does it seem like a lot of growth? So for one, we already discussed. So does it seem like a lot of growth? Well, let's look at that. So from 2004 to 2007, it went from, we have to look at the scale and estimate this. So it was above 50,000, but below 51,000, but less than halfway. So maybe $50,300, something like that. You can't get exact because it's not on an exact this line is only labeled at 50,000 and 51,000, so we can't get exact. In fact, 5,300 might be a little, or 50,300 might be a little high, but we'll go with it. Just don't say 50,500. Just because it's between these two doesn't mean it's 50,500. It's lower than that. 500 would be right in the middle. And definitely don't say something above 50,500. And then it went to, this year is easier to read because it looks like it's almost exactly on 52,000. We don't know that it's exactly. It could be $52,050 or 51,950. It's hard to tell from a graph those types of small changes. But since it does look like it's right on that line, we'll go ahead with 52,000. So was that a lot of growth? Well, if we find the difference, so if I take, 52,000 and I subtract 50,300, how much growth was that? Well, that comes out to be $1,700. And remember, that's a yearly income. So for a yearly income, increasing your yearly income by $1,700, that's more than $100 a month because $100 a month would be $1,200. So is that a lot of growth? In terms of income, I don't know that I would consider it a lot of growth. Would I consider it insignificant? No, but probably wouldn't call it a lot of growth. And again, it's, if we divided that by 12, by the 12 months in a year, we get 17,000 divided by 12 to be about, I'm sorry, 1,700 divided by 12 to be about $141.67. So I'll just say about $141.2. So that's an increase of about $142 a month. And of course, everybody'd like to have an extra $142 a month, but in your budget as a whole, how much difference is that going to make? So, and again, that depends on what your income is. If you have a high income, $142 might not make much difference. If you have a lower income, $142 can make a huge difference. It says, now let's look at graph 2. With just a quick glance, what does this graph tell you about average household income? So we're looking at this graph and we're saying, okay, well, we've got 1999 to 2009. We have this labeled over here. And it looks like the average income remained fairly steady. Didn't go up much or down much. It remained fairly flat. But this is curious. If you go up here, same title, average household income. Same label over here, average household income. Same years down here. These are the years. So why do these two graphs look so different? Well, the reason is the only change is you notice over here they go by thousands, and right here there's these funny little wavy marks that means that the graph has been split. So they started here at 0, and then the first mark they made was 48,000. So on this graph, it looks like this space is worth 48,000, whereas each of these same size spaces, or same size changes in height, are only $1,000. Well, that makes the graph look significantly different. And in fact, having a split graph is considered somewhat deceptive or misleading, because visually these look like big changes to us because of the way that the graph looks, because this looks like it started here and came down about a third of the way down the graph, if not more, and so it looks like it had this huge drop. Whereas here, if we look, it doesn't look like much of a drop when we're actually going by, starting our graph at 0 and going by equal spacing all the way up. It makes it seem fairly flat. Does graph 2, I'm going to scroll this up here. Does graph 2 contradict the information shown in graph 1? Well, I don't know if I would say, and let's write down an answer here. It looks like less change because the y-axis is not split. From 0 to 48,000. So hopefully that'll help you remember that when you go back to look at those notes when you're doing your homework. So this makes it look like a lot less change because it's not a split graph. So do they contradict each other? I don't know if we would say they contradict each other. They have the same data, but I would say not contradict, but it emphasizes that there is not as much change as the split graph shows. So, they both hold the same data. They're both technically correct graphs. It's just that one with the split axis makes it look like the changes are more dramatic than they actually are. Okay, so question 5 asks, what's the key difference between the two graphs? And we already discussed that. How does this affect the visual impression? So to summarize, the difference is that graph 1 has a split y-axis. That's the axis that goes up and down on the left side. The split graph emphasizes change. Ran out of room. It's down here. Okay, so graph 1 has a split y-axis, and that split emphasizes the changes. Let me add to that, the changes in the income, whereas up here, with there not being a split graph in graph 2, it shows that there's really not as much change as it appears to be in the split graph. The split graph is a little bit misleading, the first graph. The second graph is more accurate without the split axes. It makes you realize that the change wasn't as much. So now they get into kind of some philosophical questions. Who might want to publish graph 1 in the newspaper? Who might want to publish graph 2? Well, as we talked about with the advertising, if you're talking about graph 1, which emphasizes that there was a lot of change in income over this period, and that the income mostly dropped and ended up lower than it was when it started, somebody who was going to publish the graph this way would probably be trying to emphasize or convince people that there was a problem, that the average household income has dropped, that it's decreased more than it's increased. So this would be someone who's trying to emphasize that there's a problem, maybe someone who's not happy with the administration that was in place during those time periods, or something along those lines, but definitely somebody who's trying to emphasize a potential problem. Someone who was going to publish this graph, and remember this graph is less misleading than this graph is mathematically. We're not going to get into any political or philosophical questions, but as far as mathematically, this graph is considered more accurate and less and more of a better representation, a more it's considered to be less misleading or a better representation of the actual data, the second graph. So the second graph would be someone who's trying to convince you that, hey, there hasn't been a lot of change in the average household income over this period of years. It hasn't dropped much, it hasn't raised much, it's held pretty steady. And so this graph would be someone who, again, is trying to say that there's not a problem, that the current administration is doing a good job, or the past administration, I should say, the administration between these 2 years. Whether they were trying to convince you of, whatever program that they were trying to look at that has to do with household income, jobs, or cost of living, all kinds of different things. Okay, so now what our materials say here is it says you saw above how the visual impression made by the graphs was deceptive. This is why it is good to think about the actual data presented in graphs. One way to decide if there is a lot of change is to calculate the relative change. This is something that's going to come back, and we're going to use this relative change a lot over the next few units. So it's really important that you understand this. So relative change, in this case, is the ending amount of income, subtract the beginning amount of income, and divide by the beginning amount. So what you're doing is you're looking at the amount of change compared to where the amount started at. So I've written this for some students, and we discussed 6. I've written this for some students as just in general, and it seems to help them some to think of it as end minus start over start. A little bit more cryptic than what this has here, but easier to remember. So the relative change is the end, whatever the value is at the end, minus the start, whatever the value was at the start, and then divide it by wherever it started. So in this case, what was the relative change from 2004 to 2007? Well, we figured out the actual change here was $1,700. So we'll write that down. So this would, for this case, would be, and again, we're going from 2004 to 2007, not the entire graph. So from 2004 to 2007, we ended at 52,000. So that's the end. And we started at 50,300 was our estimate of the starting value. And then we're supposed to divide that by the starting value. So in this case, that would be 50,300. So, calculation-wise, that would be that $1,700 that we already calculated above, divided by 50,300. So if we grab our calculator, a change of $1,700 from a starting amount, a starting income of 50,300. So what was that? That was roughly a 0.0337, and I'm going to round that to the third decimal spot, which is this 3.033. But I can't leave that a 3 because it's got a 7 after it. So I'm going to round this 3 up to 4, and I'm going to write this as 0.034. So this is approximately 0.034, which is 3.4%. So it was a 3.4% change, which is not insignificant, but it's not a huge change. Again, if you look up here, it looks like it went, nearly a third of the way across the graph to get from here back up to here. And it looks visually a lot more than it actually was. It was really only about a 3.4% change. The graph also shows a period of rapid decline in income. Determine the relative change for that period. So give me a minute. I'm going to give us some space here and we'll answer these questions. Okay, so we'll go back up and they want us to look for that relative change that was a decline. So if we go to this graph, they don't specify, but from the way they worded it, it appears to me that they're looking at these 2 years, from 2007 to 2008, and they want us to get the relative change of that time period. So, is that number 8? So for number 8, we have, we want to get the relative change. Again, it's not the, what we call that first number we got, that 1,700 amount, where how much it actually changed, we call that the actual change. So it wasn't an actual or absolute. So it wasn't the absolute change in value that we were looking for, the $1,700. It was the relative change that we were looking for. So that top number would be considered the actual or the absolute change. It absolutely changed $1,700, but they wanted us to compare that to where it started. So overall, in comparison to where it started, it was considered, so this is an absolute change and this is the relative change, 3.4%. So in this case, we need to again do end minus start over start. And so in this case, the end appears for these 2 years like it stopped at about 50,000. Looks like it's right on that mark to me. So 50,000. And where did it start? It started at 52,000. That's that same value we had before. Okay. And how long did that take? Well, that was only not how long did that take, but where did it start? So end was 50,000. It started at 52,000. So we're going to put 52,000 under here. Now this is going to be a little unusual because on top we're going to get negative 2,000. So it dropped $2,000 from 52,000. So as a relative change, if we take 2,000 and we divide it by 52,000, that gets us, sorry, I was doing it on my own calculator. Let's do it so we can all see it. So 2,000, I'm going to make that negative, divided by 52,000 is a decrease of about 3.8%. I'm not going to round this 8 up, even though it's close. This is only a 4 here. So I'm going to not round this 8 up, and I'm going to write it as negative 0.038. So this is approximately negative 0.038, or a drop of 3.8%, roughly. So that was more of a drop than we had of an increase over here of only 3.4. But that makes sense because before we went from here to here, and then we started here again and we went down, and it came down lower than it had been before, even in 2004. So it dropped 3.8% in that 1 year. So that was the most significant decrease that they had during that time period. And then number 9 says, write a contextual sentence about your answer to question 8. Refer to the resource writing principles if needed. So they just want us to use good verbiage with this. So lots of detail. So from 2007 to 2008, so whoever's reading the sentence knows what we're talking about, there was a relative change of negative 0. Nope, that's not what I want to say. Of negative 3.8% in average household income. And then if I was trying to, again, convey some good information to somebody, I would probably even go a little bit more specific. I would say it dropped from, try to squeeze this in here, it dropped from 52,000 to 50,000 per year. Okay, so 52,000 per year to only 50,000 per year. Okay, so now on to lesson 4D, and we're still talking about representing data and such, but now we're talking, this theme of this is civic life, so we're looking more at like how a person fits into the world or fits into or helps society. And so what our two graphs have here are a 2010 U.S. population and the 2050 U.S. population, projected of course because that's in the future. And for the 2010 U.S. population, we have a real broad spectrum here of people that would be considered non-Hispanic versus people that live in the U.S. that are Hispanic. So over here we have in 2050, well, let's go back to 2010. So in 2010 we had non-Hispanic as 84% of the population and Hispanic as 16% of the population. So it's been projected that in 2050 the non-Hispanic population will be 70% and 30% of the U.S. population will be Hispanic. So the question is, true or false, this pair of graphs predicts that the number of non-Hispanics in the United States is expected to decline. Well, at first glance, it says here in 2010 that it's 84%. When we come over here, it says that the Hispanic, or the non-Hispanic rather, in 2050 is supposed to be 70%. So at first glance, if you're not thinking about the details of the mathematics, it does look like the number of Hispanics or non-Hispanics in the United States is to decline. And it went from 84% to 70%. Isn't that a decline? Well, the problem is when you're looking at that, remember that a percentage is out of the total. So they're asking, is the number of non-Hispanics in the United States expected to decline? Well, the percentage of non-Hispanics is expected to decline, but does that mean there's actually going to be less non-Hispanics in the United States in 2050 than there is in 2010? And we would have to know what the actual population is in order to determine that. So be careful, a number is not a percentage. So just because the percentage of Hispanics or of non-Hispanics, sorry, I keep messing that up, just because the percentage of non-Hispanics in the population is expected to decline does not necessarily mean that there's going to be actually less non-Hispanics. There's probably, if you think of it reasonably, there's probably going to be more Hispanic population and more non-Hispanic populations. I mean, over the next, well, this is 40 years. Now it would only be about 33 years. But still, clearly we expect the population to grow over that time period. So the total population is going to grow. So we don't know what this percentage is until we calculate what part of, or what that means as far as the total. So now the U.S. population in 2010 was around 310 million. So let me write this down. So this is 310 million here. And in 2050, again, it's just a projection because we're not there yet, but it's expected to be about 439 million. So there's supposed to be 439 million people in the United States estimated in the year 2050. So now let's look at how that relates to the percentages. So for number one, let's put down that we need to know what the total is, total population is, in order to know how the actual numbers change. Okay, and again, percent increase does not necessarily mean an absolute increase. Or decrease in this case. Okay, so looking at number 2, for part A, it says estimate the number of Hispanic and non-Hispanic Americans for each of these years. So in this year, we had 310 million. And there's a couple different ways to do this, but I'll just pick one and go with it. So 310 million, and we want to know 84% and 16% of those. So I'll figure out the 84% first. So 84% as a decimal would be 0.84. And if I calculate that out, 84%, I'm going to do it in reverse, but it'll be the same. 0.84 times 310, so 84% times 310 million, gives us that currently, or in 2010 at least, there were 260.4 million non-Hispanics. Well, there's a couple different things we could do to get the number for the Hispanic population. We could either just subtract this from 310, so we could do 310 million minus 260.4 million because together they should total 310, or we could start over and do 310 million times 16%. Either way would get you the same answer. So 310 times 0.16 gets you 49.6. Again, if I had done 310 minus the non-Hispanic population, that would have given us the remaining part of the population that was Hispanic, again 49.6. So either way is completely appropriate. And I could have started with the Hispanic population and then either subtracted or multiplied to get the non-Hispanic population. So this is 49.6 million that are Hispanic. Okay, so now for part B, of course we want to look at, sorry, that's not part B yet. We're still on part A. So now we want to look at 2050. So this was in 2010. We'll put that off to the side here. Now we want to do 2050. So we're going to do the exact same thing, but with the 439 million number and the new percentages. So we have 439 million, and for the Hispanic population, it's supposed to be 30%, and so that would give us 439 times 0.30, or 0.3 would get you the same thing, is 131.7. Hold on, I'm going to do this differently just because I don't want to be confusing doing it the opposite way between the two problems. So let me back up on this. I'm going to do the non-Hispanic part of the population first just because I did it up here, and so I want the numbers to be in the same order. So let me try that again. Let me start with the 70%. So 0.70 would give us 439 times 0.70, or 0.7, and that gets us 307.3 million that are non-Hispanic. And then we can subtract that or multiply by 30% to get the remaining part of the population that would be Hispanic. So we have 439 times 0.3, which is 131.7. And if we had subtracted 439 minus 307.3, we would have also got 131.7. Okay, sorry about my cryptic little abbreviations there. So now let's go back. It says, does your work support or refute what you said before? Well, we weren't sure before, but it looked like there was an increase because of the way the percentages looked. But now, if we look at these actual numbers, is the number of non-Hispanic people in the United States decreasing? The answer is absolutely not. It's going up by almost 47 million people. So the non-Hispanic portion of the population is going to go up by 47 million over between 2010 and 2050. So why did the graph look the way it did? Well, because the Hispanic population grew much more quickly compared to where they started. So the Hispanic population started at not quite 50 million, and it's going to more than double. So even though 47 million is, of course, a significant change in population, going from not quite 50 million to over 130 million is more of an increase. So they gained more of the percentage in 2050. So it says here, one newscast reported that the Hispanic population is expected to grow by 14% by 2050. Another station reported that it's expected to grow by 165%. Which report is correct, or are both or neither correct? Well, I'll show you where they both come from, and then we'll talk about which one is actually the more accurate mathematical way to explain it. So if we look at the numbers that we got here, the Hispanic population is supposed to grow again from 49.6 to 131.7. And so if you look at that in terms of absolute growth, 131.7 minus 49.6, this is where it ended, this is where it started. That gets you And if you can do stuff in your head, that's fantastic. I'm going to do it on the calculator here just so everybody's on the same board. Same boat, I should say. So we've got on board or on the same boat. Mixing up my sayings here. So the difference between that is 82.1 million people. So there's an increase of 82.1 million people in those 40 years. So where are we getting the 14%? Well, the 14% is simply the change from 84, I'm sorry, looking at the wrong population, is simply the change from 16 to 30. So from 16% to 30%. That's where they're getting the 14%. But that's not a very accurate way to describe that, because growing by 14% would indicate you're only going to gain 14 people for every 100 people that you had. Well, there's a lot larger change here. This 165% is actually more accurate the way that you word it. You can either say that the Hispanic population is expected to grow in proportion by 14%. It's supposed to gain 14% total proportion of the population. But if you want to say how much the population is actually expected to grow, this is the more accurate. And how they're doing this is they're doing it with relative change. So remember, this is our end minus our start. If we divide by our start, which was 49.6 million, that's where we're getting, this comes out to be approximately 165%, because it comes out to be 1.65 when you divide. So 165%. Now, over 100% means that it's more than doubling. A 100% increase means it's gone from where it was to 200%. So from 100% to 200% would be doubling it. So in this case, we're more than doubling, which fits here, because this is, again, roughly 50. A 100% increase would be going to almost 100 million, but we've gone beyond that. So that's where we get that 165%, because this comes out to be 1.65, and then we shift the decimal 2 spots to get our percentage, and we get 165%. So let me show that on the calculator real quick. So 82.1 divided by 49.6. Usually we're used to the number on top being smaller than the number on the bottom, but in this case it's not. They've actually rounded this wrong, so I'm going to fix this. It's actually 1.655, and so it should be 166%. Okay, so I don't want to leave this mathematically incorrect, so we'll fix this. It actually is going to grow by, if you round it accurately, it's going to grow by 166%. So now it says, this illustrates an interesting twist to absolute and relative change. If your original quantities are given as percentages, as these were, then the absolute change should be expressed as the change in percentage points, not a percent, because a percent is a relative change. So this is a common error often seen in media. So there's a couple different things. You could say it's either the population is going to grow by 82.1 million, you could say it's going to change by 166%, or you can say the total proportion of the population is going to increase by 14%. You just need to say that that's the total proportion of the population that's going to increase, not say the population itself is going to increase, because the population itself is increasing by 166%. So now we're going to look at another set of graphs here, and it says let's apply what we know to what is called the U.S. gross domestic product. So gross domestic product is the value of all goods and services produced in the country. The U.S. national debt is the money the federal government owes, which is different than the deficit. The debt is how much we actually owe, whereas the gross domestic product is the value of all goods and services that we produce. So we produce all kinds of goods and services. We produce, we have food, we have products that we produce like vehicles and clothing and things like that that are produced. There are services that are rendered to people in the United States, people outside of the United States. It doesn't have to be just in the United States. It could be a product that's sold overseas or a product that's sold in the country. But it's all goods and services that are produced. So like all the work basically that all Americans do over a year, translated into money terms for all the goods and services that they have produced, how much is that worth? So it's like the value of our workload over the entire year. The U.S. national debt is what our federal government owes to whatever entity it may be. Usually it's another country. Not a social studies teacher, so I'm not going to go into a lot of detail on that because I'm sure I'll say something wrong. But it is the money that we owe. That's different than the deficit. So, and you can look that up if you're interested. So the graphs present the same information, though in significantly different ways. So here we have the U.S. national debt by year. So this is the debt in trillions of dollars, not even millions or billions, but trillions of dollars. So we have, this would be 0 trillion, 2 trillion, 4 trillion, 6 trillion. So here we weren't even to 1 trillion yet. Still not at 1 trillion, still not at 1 trillion. Right here look like we're right at about 1 trillion, and then a little over 3 trillion, and so on. So the question is asked, oh, and notice this starts at 1950 and goes to 2010, so it's a 60-year time span. So the first question says, consider the statement, the 2010 national debt is way out of hand and has never been higher. Do you agree or disagree? Again, usually when someone produces a graph, they're trying to elicit a response. Not always, but oftentimes they're trying to elicit a reaction or a response for whatever they're trying to support. You have to remember when you're looking at things in newspapers and magazines and on the or hear it on the radio or watch it on TV, that almost anybody that's presenting that has some sort of agenda. Again, not going to go into a lot of political things here, but over the last 50 years or so, newscasting has gone from trying to be very non-partisan and very just giving you the facts to having a skew one way or the other. And different news entities have, difference as to how far skewed they are and which side they skew. So they might be a little skewed right, a little skewed left, or greatly skewed right, greatly skewed left. There are some that are more in the center, and try to give just the facts. But you have to be aware that that's out there and not take everything at face value. So the 2000 national debt is way out of hand and has never been higher. According to this graph, I mean, it certainly looks like it. It's never gone down. It's kept increasing. In 1950 we were looks like we were at less than half a trillion, and now we're way up to, approaching 14 trillion. We're probably higher than that because this is only 2010. So I don't know. According to this, maybe. It looks like it. I mean, it never went down. It never decreased. And it went from less than 1 trillion to almost 14 trillion from 1950 to 2010. So this is what they're saying when they say these good writing techniques. So we want to give lots of information. The national debt never decreased, and it went from less than 1 trillion to almost 14 trillion from 1950 to 2010. So, it seems that statement is supported. So let's go on and look at the second graph. The second graph shows the same information, but it's represented as a percentage of the GDP. So the GDP is the federal debt as a percentage. So what they're doing here is they're taking our debt and they're comparing it to the goods and services that we produce. So think about it as your own personal income. So if you spend $50,000 a year, is that a problem? Or say you're in debt by, let's think of something more reasonable. Say you have a credit card debt of $10,000. Okay, so if you have an income of $22,000, a debt of $10,000, I'm going to write this down up here. So if you have debt of $10,000 versus an income of $20,000. I think I said 22, but we'll change it to 20. That means that $10,000 compared to that $20,000 you make means that you have a 0.50 or 50% of your income currently as in debt. So you would have to work 6 months without paying any other bills and without having any other money. You'd have to work 6 months to pay that money back compared to your income. So how does that compare? Well, is $10,000 a lot? Well, it depends on what your income is. So let's say you had a debt of $10,000, same debt, but an income of $120,000 instead of $20,000. Well, how does that compare? So it's the same amount of debt, but we have a higher income. So if we say $10,000 out of $120,000, that comes out to be 0.083 roughly. So 0.083, which is about 8.3%. So someone who is looking at finances of these two individuals, this person, they would say that this $10,000 debt is probably very concerning. For this individual, that's not that much because it's only 8.3% of their total income. Still not insignificant, but it's not nearly as much of a concern as someone who has a debt that's 50% of their income. So this is what we're going to kind of look at with this debt as a percentage of the gross domestic product. And let me just say one more thing. So like this person would have to have $60,000 worth of debt before it would be concerning. So not before it would be concerning, but before it would be comparable. So this person could have $10,000 of debt and they'd be at 50%. This person could be at $60,000 and that would be 50% of their debt. So if we look back at this graph and we consider this statement, remember this is looking at the debt compared to the gross domestic product. So the debt of the country compared to the income of the country roughly. So if you look over here in 1790, it looks like we were at roughly 30%. Our debt was 30% of our income. So the debt that we owed was about 30% of what we produced with the gross domestic product. That decreased to in 1838. It was very looks like it's zero. It may not have been zero. It may have been below zero actually, but our income, our debt to income was at zero. In other words, we were making as much as we owed. If you come up to this year over here, then it starts to get into a positive again, and then with the Civil War, and they kind of marked some things, which is helpful. In 1870, or a little before 1870, at the time of the Civil War, it rose up to back up to, it looks like about 30% or a little bit higher again. So we were at our debt was about 30% of what we produced in a given year. Then it declined after the Civil War. Then it popped back up during World War II. Wars are typically hard on a country's economy. Then it declined, and then we had the Great Depression. So during the Depression and into World War II, so we had the Depression, a war, huge war, followed by a depression, followed by another huge war. Our debt went up to, it looks like it's above 100%, because this would be 100. Here's 80 and here's 120. Yeah, so it looks like it's above 100%. In other words, we owed more than we were making or producing in goods and services in a given year. Then after that, it declined again into the 60s and the 70s, and then it looks like in the early 80s it started to rise again. We had a recession. went down, and then it's come back up. So this is projected in the future. We're at about right here right now because this is 2014. So this was the data they had up to that point of this graph, and this is 2030. So this is like 13 years in the future projected. So we're roughly about here now. So if you look over, that looks like, it's kind of hard to read because it's so far over. It looks like it's maybe a little under 80, maybe 75%. In other words, we have a debt to income ratio. Our debt is about 75% of what we produce in goods and services in a year. So now, having that big long discussion, consider the statement, the 2010 national debt is way out of hand and it's never been higher. Well, our debt did go up, but our gross domestic product also went up. So it continued to go up steadily, but if you look at it in comparison to our gross domestic product as a percentage, it actually has gone down, up. It rose terribly high during World War II, then it dropped again, and now it's on the rise again. So is it way out of hand? Possibly. I mean, it's approaching closer to what we had during World War II, which was our worst time. We're not there yet. We're still below that right now, but it's projected that it's going to get worse. Will that happen or not? We're not sure. But has it never been higher? No. The highest it was during World War II if you compare it to our gross domestic product. That would be our most concerning time because our debt to income was above 100%. We were spending more in a year than we were making. Now we are not spending, but in debt more in a year than what we make. So if we had worked an entire, if the country had worked an entire year and given every penny of every goods and services that we made in that year to our debt, it still wouldn't have been paid off. Now, if that were a possibility, if we could give all that gross domestic product, all the goods and services that we produce, all that income from that, we could pay off the debt in less than a year. Obviously, that's not possible because we need to put the money other places. But it's better now than it was back in this day and age. So I would say way out of hand, possibly. I mean, we're approaching some of our worst times. But never been higher, I would say that's not the truth. The highest was during World War II. That was our most concerning time if you consider our actual debt to income ratio. So I hope the video for the 2 videos for Unit 4 have helped. I know these were a little longer. I just kind of go with what's there and what I feel needs explaining. So some of the videos will be longer, some will be shorter. I know I think Unit 3 was shorter, and now here Unit 4 is a little bit longer. So anyway, I hope it's helped. These videos definitely aren't mandatory, but I would hope you would watch them, and I hope they would help you with your homework. And we'll see you back next week for Unit 5.